Hi all, this is chapter 17, lecture 17 on three-dimensional solids. I did post one the other day, but there was no volume, so this is the corrected version. Sorry about that. Okay, so when we start to talk about 3D objects, we want to first talk about some definitions. So the first thing we're going to talk about is a solid, and a solid just references any kind of three-dimensional object or shape. So this is any 3D object or shape. Okay, so a generic term for something 3D. So this could be a triangular prism. Could be a pyramid. Excuse my drawing of three-dimensional objects. It could be a cylinder. Could be a cone. Could be a sphere. Could be something else that's kind of wonky, like hourglass kind of shape, right? Anything that's three-dimensional is considered a solid, okay? That's filled in. All right, then a polyhedron, this is very similar to the idea of a shape versus a polygon. So a shape is any kind of closed figure or a closed figure, and then a polygon is a special kind. Same thing for a polyhedron. A polyhedron here is a solid that consists of, I'm going to say the word flat here, polygonal regions. Okay, so in this case, your triangular prism still counts because they're all flat polygons. In this case, rectangles and triangles. Your cubes count. Your pyramids count. Sure thing. What doesn't count here are things that have rounded edges. So no spheres, no cones, no cylinders, nothing of that nature. Nothing that's rounded. It has to be flat. Okay. A face, then, is the flat polygonal region on a polyhedron or solid. Okay. So that means when I think about that triangular prism, this right here is a face, and this one is a face, and all the other ones that you can't see when I draw it from this angle are also faces. Okay. When I draw my pyramid, let's go for a square one this time. This is a face, and this is a face, as is the bottom. Okay. Now we did say on a solid as well, so I can look at the cylinder and talk about this face and the one that's on the bottom, right? And then you can actually talk about the face that's kind of wrapped around there. Now the face, you can't really talk about the one that's wrapped around because it's not really polygonal, but we won't get into that. We can still... Okay, and again, the circles aren't technically polygons, but we're going to let that fly for now. We'll still refer to it as a face. Edges, then, on our polyhedrons or solids, this is a line segment where two faces meet. So if I'm drawing my shape, then every line that I draw is an edge, right? So if that's my triangular prism, each of these lines is an edge, right? It's where two of the faces meet. For a vertex, or for plural, we're going vertices. This is a point where two edges meet. And this is true whether you're on a polygon or a three-dimensional surface. So if I go back to that triangular prism, then each of these dots are vertices. Same thing on my square pyramid. Each of these are vertices. Oh, I think I missed an edge. There we go. Okay. Okay, and those are all the pieces of our three-dimensional solids. Okay, so let's jump into naming some things. So the first thing that we should know is this term right here. I already have it written for us. And then I'll fill in these below a little bit later. So a regular polyhedron. Okay, so a regular polygon, right, back in the last section, was a polygon that had all equal angles and all equal sides. So that's going to kind of scale up to talk about a regular polyhedron by saying that all of the faces are going to be congruent, meaning they're all equal, all the same, and those faces are all going to be regular polygons themselves. Okay, and there are only 5 of these. You can only do this 5 ways. It sounds like you should be able to do more, but you can't. So this one, if you take a look at this first one, it has 4 faces, and each of those faces are identical, congruent, equilateral triangles. I may not look at it because of the picture, because when you draw three-dimensional objects, they may not look perfect. Because it has 4 faces, we name it by the number of faces, and this is called a tetrahedron. Tetra meaning 4. Tetrahedron. So 4 congruent equilateral triangles for faces. The next one, I'm going to give away all my secrets here because I didn't erase anything. Let me do that real quick. Okay. Is just a standard cube. So a cube is the second of our regular polyhedra, right? Polyhedron, O-N is 1. Polyhedra, when A is multiple. So our second polyhedron is a cube, and this has 6 square faces. You can count them up. Next, we have something that has 8 sides. You can try to count them there on this, what looks like kind of like a diamond, a three-dimensional diamond. And each of those is an equilateral triangle, and they are all identical. So we call this, it has 8 faces, and so this is an octahedron. And it has 8 faces. Next is the one that I think that looks like a deflated soccer ball. And in this case, each of the faces is a pentagon, a regular pentagon, and there are 12 of them. So these are 12 pentagonal, let's see if I can spell it right, faces. And because there are 12, 12 is dodec, just like a 12-sided polygon is a dodecagon. Dodecagon. This is a dodecahedron. So dodecahedron. Okay, 12 pentagonal faces. All right, moving back up here, the last of our regular polyhedra. This one we're back to triangles. So this has 20 triangular faces. And they're all congruent. 20, this is going to be an icosahedron. Icosa meaning 20. So those are our 5 regular ones. There are no other ways to do this where every face looks identical and it closes properly. Okay, if you try with others, it's just not going to close up the way you want it to. Okay, but there are lots of other polyhedrons and so polyhedra. So let's talk about those. This next one, notice that we've got a triangle on this end, a triangle on this end, and then rectangles connecting those. This is a triangular prism. I drew this a few times for you. Okay, triangular prism. We're going to talk in a little bit about how you name these, but for now, just know this one's a triangular prism. The next one, notice that we've got squares on this end and a square on this end and rectangles connecting them. So this is a square prism. And next, our last one on this page, notice that I've got hexagons here on each end, and then those are connected with rectangles, and that makes this a hexagonal prism. And then we move right along to page 2, and let me erase these so we can do them in real time together. All right, in this first column, now I've got a triangle here on the bottom, but now instead of rectangles connecting 2 of them, I have the fact that these lines come up to a point at the top. And that means that I'm working with a triangular pyramid. A triangular pyramid. On the next one, it still comes to that point at the top up here, but now my bottom is a square. And so that makes this a square pyramid. Next, this one. If we count up the sides on this base figure, there are 5 of them. And that makes this a pentagonal pyramid. And then lastly, notice that our last column over here, up here in the title, this says solid, where over here it said polyhedron. So this is where we get back to the ones that have the curves on them. And these are, I think, you're more familiar with. So this first one is a cylinder. The next one is a cone. And the bottom one is your sphere. And those are all of the shapes that we're going to identify at this stage. In the next couple of videos, I'll go through the next couple of pages in your notes, and we will talk about how to name them, how to find a nice little formula, how to do lots of different things.